And welcome to the latest episode of the Dart build. As you can see from the pretty picture, a wheel. Well, the wheels are not going to be the feature of this episode because they're already turned, but they do need a modification. If you look down in this corner, the recesses go into the spokes. The wheels that are turned already, bought ready turned, that recess isn't quite deep enough, and there isn't a recess at all on the back. So that modification has got to be made at some point, but one of the items I'm looking at are these counterweights. I'm just ordering them from the laser cutters, cheating a bit there, I know. I could have done them on the rotary table. And they're all plotted out, so they will laser cut them for me. Different thicknesses, of course, and then they've got to be filled with lead. The main item that I'm looking at on this picture is this, the crank pins, of which there's 4 of silver steel. 3/4 inch diameter to start with, turned down to go into the nice reamed hole. Well, I bored it because I haven't got a ream of that size. Precision turned here, and then a nice thread, and there is a nut which goes on the end which gets pinned in place. So what I will be turning are these 4. Well, I'm not going to bore you with turning 4. You'll see 1 being turned, and you'll have to imagine me doing the rest. There's no point rinsing and repeating that amount. So the next step is to go to the workshop, set the camera up out there, and then make these little beasts. Alright, let's go. And make my lathe. I don't think it's come up in any of the other videos. It's an Amadeal 1022, which is now I think a 250 by 550 or something, and they've gone metric on it. The same lathe. Bought with a fitted DRO, which has been a godsend, and it is very accurate. Lovely bit of kit to work with. I've not had any problems with it in the past 2 years. First operation, traditional face off. So you've got a nice square surface to work with. With that done, zero the DRO and start reducing, and I can't remember what dimension it actually was. It was a weird decimal number that will fit into the wheel. I turned them down about 2 thou over size so that they will be a nice tight fit, interference fit. Bit of Loctite just as belt and braces. Quick measurement with a micrometer. For doing accurate work I prefer the micrometer to a vernier. Yeah, just me. If you trust your vernier, then use it by all means. I'm lucky that I've got micrometers up to about 6 inches, I think now. I've built them up over time. So I've worked out how much more to take off, take it down to the required measurement. It was just rinsed and repeated several times. It was, I can't remember what the size was. Short-term memory goes, old age. Aging myself. When it turned down to size, it was just given a polish with some Scotch-Brite. Not a high polish, so I wanted to leave a little bit of texture there just to help the Loctite. I've got every faith in it, but having measured the hole in the wheel, they were all the same except for one, which is about 3 thou bigger. So just to make sure each one of the crank pins was turned to fit the wheel, each one checked and numbered accordingly so that each one will go into the appropriate wheel, and there shouldn't be any problems. There will be a special gadget putting an appearance in, possibly very shortly. Yes, there will be. This is the Scotch-Brite. No, sorry, it's just probably the final cut. I was concerned about having got a nice finished surface, marking it with the 3-jaw chuck. Yeah, okay, I have got a set of soft jaws which are on top of the headstock, or brass shims that will go in, but yeah, you're not quite gripping as tight. So I have got an alternative. Quick check with the wheel, physical, and yes, it just enters, just. So that is an acceptable fit. Put a chamfering tool in to just knock the sharp edges off and deburr the flange. Not a standard thing. So as I was saying, I was concerned about marking. So quite some time ago I did actually buy a rather special chuck. I bought the economy version, and it's I think it's number 3 Morse taper. I bought a piece of studding and a nut. A friend gave me a nice big washer, the right size. So it's assembled more or less the same as a drawbar for a vertical mill. That's the whole. That's the size for the wheel. Now just polishing it up. It was then parted off, and for some reason I can part silver steel off brass, no problems. Comes to steel, and the carbide tip I use snaps. Yeah, I don't know why, not sure. Possibly going slightly too fast, not fast enough, temperamental beasties. But silver steel, I can part it off, and I'll wear the tip out before I break it. So, yeah, that's and there is my collet chuck holder, ER32, and I did put a DTI on it, and absolutely no wobble at all, totally zero all the way around. So even though it was an economy version, about half the price of buying a proper faceplate and with collet chuck mount on it, it works perfectly well. The only advantage with the proper one would be it doesn't stick out as much. I can live with that. Live with my ex-wife long enough. So, yeah, faced off now, zeroed the DRO, and then cut it back for the length, which was the length of the bearing surface and the length of the thread. So just a case of rinse and repeat, and get it down to exactly ½ inch. I got it down to ½ inch. By the time I actually put the Scotch-Brite on, it was about 1 thou under, and there is a tolerance of 2 thou minus and plus 0. So perfectly spot on. Very happy with that, and I don't think it was chance. I must be learning something. Yeah, I hope so. Never too old to learn. With it down to ½ inch, I think this is probably the final cut, just to trim it off, and maybe down to the 5/16. It's 5/16 by 40, which is a standard Model Engineer series thread. They tend to work 32s and 40s, except the ½ inch, which I think is 26, and that's something technical, British Standard Plumbing or something, BSP. I've got most of them, so I can cope usually. Trusty micrometer. When I get it down to the right size, I use a standard die, bring the tailstock to make sure it's absolutely square. You need 3 hands, that's the only disadvantage. One to hold the spindle steady, one to turn the die, and the other to wind the handle to push it forward. I suppose one day I might do a project and make myself a die holder or 2. I think Keith Appleton, he's got loads of them he's made over the times with all his favourite dies in. Good for him. I'm too busy making bits for Dart. It's surprising actually how long it takes to set the camera up, film it, go back, do it again, and then of course you've got to, in between, you've got to do all the other bits that you're doing as well. In Mr Crispin's video, which I mentioned, he does say how much time making the videos does take up. It's worth it, I think, I hope, believe so. If I didn't, I wouldn't do it. Yep, so anyway, with the bearing surface polished up, down, turning the 5/16, ready to thread, and just rinse and repeat, DRO numbers, watching, standard turning operation. I will admit I did make a boo-boo, and when I did my City and Guild, one of the things that we had to learn was operational procedures. I think that's what it was called, where you were told what material would be used and given a drawing, and you had to work out the order of the procedures to manufacture the part. And I should have remembered that lesson. It was 40 years ago, yeah, about that. And I made a boo-boo. I got it wrong. So with the crank pin finished, it's on to actually starting the nuts that go on the top. To do that, 3/4 inch silver steel back in the 3-jaw chuck, centre drill, and drill it 9/32 to tap 5/16 by 40. And having faced the end, I parted it off and made 4 nuts, and to be honest, they all ended up in the bin. The plan was to thread them onto the crank pins, grip them very carefully, and mill the spanner flats in the side of the vertical mill in a square collet block. The cutter decided that it's going to take the nut off, throw it across the workshop and chew it up, all in one pass. So that plan didn't work. Plan B, this is still plan A by the way, because you'll see me bring the parting tool down to part it off, but I had drilled deep enough to get at least 2 of the nuts out of each pass. So having failed with plan A, plan B was to get the square collet block, which is on the shelf in the background, set that up with 3/4 with the crank pin in an appropriate collet, and then mill the flats, turn it 180 degrees, mill the other flat. So then bring it back to the lathe and part them off. So yes, it was a good exercise in producing scrap. If it had been brass, I would have put it in the brass bin, but silver steel, it went into the plastic rubbish bag. There we are. Touched off on the top, touched off on the side, dropped it down, I think it was 0.093, and went in about 46 thou. And the next and final operation, final but one, is to spot drill and drill down 1/2 inch deep, 2.2 millimeters, which is 8BA clearance size. Having drilled that hole, to go through the remaining bit, the last 1/4 inch, with 1.8 millimeter. Then to tap that bottom hole 8BA. Another problem. 8BA taps, being thin, are very short, so it wouldn't reach. Luckily, the way I had it set up, with parallels either side and underneath and a stop at the back, I was able, that was done so I could bring each one back into identical place, rather than set up for each one. And it was a simple matter to take the collet block out, turn it 180 degrees, and lo and behold, the drill went straight down the hole, lined up perfectly. So I must have done something right. For a 3/4 inch deep hole to come out absolutely spot on and exactly where it should be, I was very impressed. So yeah, drill 2.2, lots of coolant, but 2.2 is very thin, very easy to snap, and an 8BA tap is even easier to snap. And heart was beating like a drum, but no tap was broken on this one. I'm not going to push my luck and say no tap broken ever. We've all done it, particularly small ones, and hopefully the other 4 will go once I get the correct nuts to go, or bolts to go in. They've got to be inch, half threaded, so that they will actually go in when the not eccentric straps, the connecting rods are in place, and then the pins are put in with a bit of Loctite to hold them in place. Hopefully never take them off again, at least not quickly or easily. Yeah, I can imagine the 8BAs will snap off. So anyway, drilled through, turned the block 180 degrees, and very, very carefully, very gently, with lots of cutting compound, tapped the 8BA hole. Quick polish of the heads on the Scotch-Brite wheel that I've got, and they came up very nicely. You can see that I put a 1/2 inch standard 8BA bolt in just to hold it in place. I'm very pleased with them. The next job will be the wheels. Anyway, thank you for dropping in, thank you for viewing. I hope you enjoyed. If you feel like subscribing, please do. The numbers are going up steadily.